In this final problem, we're going to put everything together and do something very complicated, which is called a ballistic pendulum. So in a ballistic pendulum, we have an object that fires into a block, and that block moves up, and we want to find the projectile speed. If you guys are taking labs right now, this is the lab for this week. So we're going to cover what's going on. So the first step is we have a bullet. We're going to have, it has a little mass m, an initial velocity v. It's going to hit a block that is connected to a rope that has capital M. And actually, I want to color code it so that people don't get confused. We'll call the block's mass blue. And its initial velocity is 0. They're going to collide inelastically. So there's a before. And then after the collision, they're going to collide so that we have a block with a bullet in it. And it has a mass of little m plus big M, and it's going to move with a v that is unknown. Note, this v here is what we're solving for. So right now, we have two unknowns, so that's not going to work. But we have an additional part of this problem. This pendulum is going to swing out to an angle of 40 degrees. So this is after number 1. I'm just going to redraw my picture. And then after, so after number 2, theta is 40 degrees. The mass is still this. Its velocity here is 0 because it stops at its maximum height. And it's going to reach some maximum height h, which is unknown. So this is a two-step process. 1, we have to use momentum here to find the velocity, big V, in terms of little v, or blue v in terms of black v. And then we have to use energy conservation here to relate theta to blue v. So our momentum here at this before is we have 0 here, and let's make it blue. PI equals 0, and for this, PI equals MV. After, we have P final is equal to M plus M times big V. So conservation of momentum states that PI equals PF. So this is MV is equal to M plus capital M times big V. So this is our first equation. and it has all these masses that we know and all of these velocities that we don't. So if we go here, the energy before has a kinetic term, 1/2 m plus blue m times v squared. U initial is mgy initial. That's 0, because we're going to say that this is our baseline. K final is 1/2 m plus m v final squared. That's 0. And U final is equal to mgy final. So we're told the length of the string. So our hypotenuse is 1500. Well, let's just call it L right now. And we're told this angle. So in order to find y distance, we have to use SOHCAHTOA. So this is adjacent, so this is cosine of theta is equal to y over L. So y is equal to L cosine theta. So this guy down here becomes mg L cosine theta. L is known, theta is known, m and g is known. So all of this is known. So we now can set initial energy equal to the final energy. So the initial energy is 1/2 m plus capital M capital V squared equals mgl cosine theta. So this guy only has one unknown, capital V. So we have our unknown capital V here, and if we can solve for it using that equation, we can plug it back in here to find this guy. So what I want to do is not plug anything in yet and solve this equation here for capital V. So that just involves us dividing by m plus blue m. Oops. So that gives you V equals mv divided by m plus v. So I'm going to take that and I'm going to plug it in down here. And zoom out a little bit. So 1/2 m plus capital M V. V we just had is mv over m plus capital M squared. That's equals to mgl. Oops, this is not correct. This m isn't right. This is m plus blue m L cosine theta. So down here, this is equal to m plus blue m GL cosine theta. So we get some cancellations. Let's cancel that with this. And then we have to square it. 1/2 mv squared over m plus m. Well, let's use our colors. squared equals GL cosine theta. We're now going to move everything, keep moving things across. So MB squared over M plus blue M squared equals 2GL cosine theta. M squared B squared over, we're now going to multiply these across, 2GL M plus M squared cosine theta. And then we divide by M squared. V squared is equal to 2GL M plus capital M squared cosine theta over M squared. Finally, we take the square root of both sides. V is equal to M plus capital M over M times the square root of 2GL cosine theta. And all of these things are known, and you can just plug them in.